The CPU helps in controlling the execution of graphics programs and it is used to process the user inputs. First one and the basic one is cathode ray tube. So this is a very basic level of display unit and the power consumption is low when it is compared to a CRT tube. Then the image quality is better compared to that CRT tube. The raster scan is less expensive as well as random scan is more expensive. Hello everyone, I welcome you all to the first unit of Computer Graphics and Fundamentals. The unit 1 is all about understanding the basics and fundamentals of computer graphics. Over here, my name is Deepa Kutnikar. I'm working as an assistant professor at the Department of Computer Science, Vidhyaashram, Temple of Excellence, MYSURU. Let's move forward and see the agenda of today's session. Yes, in the initial way, we will be learning like what is computer graphics, then followed by we do understand applications of computer graphics, then what is the overview of computer graphics, then we do learn the various video display devices and the comparison between the monitors, and there is something called as random scan and raster scan. So what is all about, we will be understanding that. Then up next we do learn graphics monitor and workstations, followed by we do learn and understand how to take care of points and lines with respect to computer graphics. So these are the things that we will be learning in today's session. So let's begin with understanding what is computer graphics. Computer graphics is a subfield of computer science on creating graphics. It means creation, storage, manipulation, and display of images using computers. So whatever we do with respect to a change in dimension or change in the property of an image, it can be considered as a change in a graphic of that image. Indirectly, we can call it as a computer graphic. All right. So let's see what are the real-time examples of this computer graphics. The real-time examples are, yes, initially games, movies, the medical imaging, then comes a car design as well as in mobile applications. So these are the very important real-time applications with respect to computer graphics, where we do find various changes with respect to images or with respect to the graphic levels. So let's see a simple computer graphic understanding over here through a flow diagram. Okay, so yeah, user is there. User is using a computer and user has something to do and he will be using or utilizing a simple computer to do that, and a computer with a graphic processor is utilized. Okay, so what is very important here, the processing of various graphics is important, and that is held once the update is done with respect to the user's requirement, then the image is displayed. So that is a simple flow of a computer graphic. So over here we can see that the various graphic levels that we want to create by using a simple computer. Great, right? So let's move forward and understand the basic applications of computer graphics. So over here we have taken applications and the simple description of that application, like where exactly this computer graphic is being utilized with respect to that field. Clear? Okay, let's see our first application, that is virtual reality. Under virtual reality, the computer graphics is used to create the immersive 3D environment in order to develop a game, in order to develop a website, or in order to develop a education or any of training procedures. The next application is augmented reality, that is AR. Under augmented reality, what happens is the real world objects are being overlaid by the digital objects in order to enhance the user experience. So in order to do this, we will be utilizing various graphics. Next application is in GUI, yes, graphical user interface. As the name itself says, whatever the interface is recommended, that's with respect to graphics, and thus it forms a very crucial application with respect to a computer. All right. So it is being used under GUI in order to enable user interaction with the computers through various icons, menus, and multiple windows. Clear? The next application that we can consider is business and data visualization. Under this, the graphics is being utilized to display business data models using various charts, graphs, dashboard designs for decision making. All right. So the next application is advertising and digital marketing. Yes, even here, this is a very, very important example, or we can say an application of computer graphics, because we all happily watch eye-catchy advertisements, isn't it? So it should be more attractive. How to make it attractive? Using various graphics. Okay, so design attractive posters, banners, and various promotional graphs wherever it is necessary. So these are the basic applications of our computer graphics. Let's move forward and understand the overview of a computer graphic. In the sense, let's understand like what are the components that is been included in order to make the computer graphics work efficiently. So the first component is absolutely CPU, which is central processing unit. The CPU helps in controlling the execution of graphics programs, and it is used to process the user inputs. All right. So the next component is GPU, which is nothing but graphics processing unit. Yes, this is a special unit that has to be installed if you want to work with computer graphic. Okay. And it is used for performing fast calculation to render the 2D and 3D images efficiently. All right. So let's see the next component. The next component is a frame buffer. All right. So the images are considered in the form of a frame, right? So now we have to consider a buffer within that frames. So why is it? Because it helps in storing the pixel information temporarily before displaying it to a user. Great. So the next component that we can consider is a display unit, that is none other than our monitor. So it displays the processed graphical output to the user. All right. The next component is a input device. As we know, the input device is used to allow the user to communicate between the various graphic systems using devices like mouse, keyboard, etc. So these are very, very important component that is must and should use in order to make the computer graphic work efficiently. Main things, or the we can say it has a main components that has to be considered are, the first one is CPU. Okay, the next one is our GPU, that is graphical processing unit. Up next, we do need a frame buffer. Okay, after frame buffer, we need a monitor to display. Then we have our input devices. So these are our important component that is necessary with respect to computer graphic. Let's move forward and understand the video display devices. So we have created a very useful and very creative graphic now. So in order to display that creative graphic, we need efficient display monitor, correct? So that's why we have to study the various types of monitors as well as the devices that is being utilized to display that efficient graphic. Clear? So in simple words, we can say that our video display devices are output devices that displays images, text, graphics, videos that is generated by the computer. So that is nothing but our simple video display devices. Now let's see what are the various devices that are available, and let's see a simple description for those devices. First one and the basic one is cathode ray tube. So this is our very basic level of display unit. Okay, so it uses an electron beam to display images. So please note, what does it use? It uses an electron beam. All right. Also, we have to note that the electron beam emits the images that is displayed on what? On a phosphor coated screen. Clear? The next device is a LCD device, which is nothing but liquid crystal display. So the LCD As the name itself says, it uses the liquid crystals and a backlight to produce thin energy efficient displays. Clear? The next is LED, which is nothing but light emitting diode. So we all are using this LED lights, LED lamps, correct? Even the monitor screen of LED. So what is the use of this? It is an advanced LCD display that uses LEDs for brighter images, and also it helps in low power consumptions. Alright, low power consumptions. The next device is OLED. This is an advanced device which is called as organic light emitting diode. Okay, OLED. Now, it uses an self-emitting organic pixel in order to provide that contrast and vibrant color. Along with it, it also provides a wider viewing angle. Okay, so that's why this is a most advanced form of display unit or display device. So what are the various display devices and what are its description we have learned here. All right. So let's move forward and see a basic comparison of these devices with respect to various features. Okay, starting with our CRT. So this is the CRT monitor that we have seen in our previous decades. Up next, we use this LCD screen now also. We do also use this LED screens. The most of the TVs work with this LED screens, and the OLED screen is the advanced screening technology that's booming in this generation. So let's see the comparison over here. We have first device and various features, important features like thickness, power consumption, as well as the image quality. So let's see what about our first device, that is CRT, which is nothing but cathode ray tube. So cathode ray tube's thickness is thick, then the power consumption is high, as well as the image quality is good. Next, with respect to LCD, the LCD's thickness. So you can observe here the thickness is thin and the power consumption is low when it is compared to a CRT tube. Then the image quality is better compared to that CRT tube. Alright. So next device is a LED. Here the thickness is very thin, as well as the power consumption is very low and the image quality is high. So you get a HD quality of images in this LED screen. Okay. Not only HD, you can also see the 4K images very efficiently. Clear? The next device is a OLED. The thickness of the screen is ultra thin. Okay. And the power consumption is absolutely low, as well as the image quality is excellent. So this is a simple comparison, and by seeing this comparison as well as images, we can correlate that the advanced technology is our OLED and it has more advantages compared to our previous display monitors, isn't it? Great. Let's move forward and see two different types of scanning techniques. So the first one is called as raster scan system. So what happens here is it is used for absolutely used in display systems. All right. Next, it works using pixels of the images. All right. Yes, this is important. Then the image is refreshed line by line. So I have an image and I do some changes to that image. How is that change updated? That's by line by line. So over here, let's see here. This is a simple image. How the scanning is happening? The scanning is happening line by line. Okay. So this is called as raster scan. So what is the advantage of this raster scan? So as we go line by line, it gives us a high quality image, and the color support that is provided is also advanced one. Up next, it gives an realistic graphics. So over here we have a small example for our raster scan. So by this we will be getting a rough image. Okay, this type of image is what we will be getting. So you might have seen while the image is in processing stage, initially it will be showing in this way. So it will be loading in the processing stage. So at that stage, we will be having these kind of images, and this is the initial image type that we get. Okay, so what is it called as? It is called as raster scan. Here we will be getting an exact idea, okay, what kind of image we will be getting at the final output. So we have considered this Pokemon image. So next, let's move with the next type of scanning, that is random scan. So now you can see a very good image that is been efficiently displayed, correct? So this is possible through this random scan. What happens in random scan? It efficiently draws our straight lines, and here it won't draws any unwanted lines. It only draws the required lines. Up next, it occurs as a vector display, and the advantage is high resolution and smooth lines. So let's see the comparison image in our next slide. So compared to last previous scan, that is a raster scan, this random scan gives us an efficient image, isn't it? Now, how is this possible? That's by utilizing algorithms. We will be using two different types of algorithms, that is DDA algorithm and a Bresenham algorithm. So what are the two different algorithms? That is DDA algorithm and Bresenham algorithms. By using this algorithms, we get an efficient and crisp image. Clear? So let's move forward and see a simple difference between our raster and a random scan. Under raster, we did learn that it goes pixel by pixel. So it is pixel based, and the random is a vector based. And the raster supports images, whereas the random supports line drawings. All right. The next is the raster scan is less expensive, as well as random scan is more expensive. Then raster scan is used, okay, and the random scan is rarely used. Why? Because of its expensiveness, and as it's vector based, it is used in a complete complex applications. For general real-time applications, our raster scan is sufficient. So see the difference of the scanning. So this is an image with the raster scan, and this is an image with the random scan. Obviously, for real-time complex applications, we have to go with our vector based scanning method, which is our random scanning. Clear? Up next, the topic that we discuss is a simple graphics monitor and a workstation. So a graphic monitor is utilized to display the graphics output, but a workstation is an high performance computer that is been designed to support the graphics. Now, what's the difference between this? If as an individual I'm working with a simple things, then a simple graphic monitor is sufficient. But as an organization, if we want to work as a department, then our graphic monitor is not sufficient. We have to go one step forward with our better and high performance computer, which is called as workstation. Clear? Getting that difference? Now, let's see the workflow of a simple workstation. Under workstation, what happens? A graphic card will be installed, and because of this graphic card, we get an efficient graphic displayed on the monitor. So over here, this is an image of a complete workstation where an organization's complete graphics designing is taken care. Okay, so let's see the examples of this workstations as well as our graphic monitors. So it is being used to display the animations as well as any CAD drawing with respect to the complex executions, and it is also used in 3D modeling. So these are the various examples. That's the real-time example. So nowadays you might have seen, if you want to construct a house, if you go with an architecture or an engineer, they will give you a 3D plan, a 3D view of your house that is created by using the graphics monitor. Clear? So that's the difference between a simple graphics monitor and a workstation. Clear? Great. Let's move forward and understand a simple point and line. So if you want to deal with the image, you can't directly go with the image. You have to start with the point, correct? Then you have to go with the line and then different lines and then a complete image. So now let's understand what is a line. Line is formed using two different points. What is point? So we have two different points here, P1 and P2, isn't it? So these are simple theory, but we have to start with basic. As it's our first unit, we have started with a simple point and then a line. Let's see the applications of our points and lines. These are used in our CAD drawings, where it is used to create accurate engineering and architectural drawings. Up next, it is also used in the engineering drawings, which is used to represent the various machine parts, circuits, as well as our technical diagrams. So this is an example of an engineering drawing. Next, it is also used in maps and navigation. So in the maps, you might have seen the lines, like if you want to go straight, it will be showing you with a arrow mark. Okay. Next, if you want to change your location or the direction, it will give us turn right, turn left along with a line, isn't it? So yes, it is also used in maps and navigations. Also, it is used in computer games. Under games, it is being used to set the boundaries as well as fixing the game environments. So these are the various applications where a simple point and lines is being utilized as a graphic. So this was all about today's session, and in the upcoming session, we do discuss about our algorithms and various curve representations. So this will be done in our upcoming session, that's in session 2. So this was all about today's session. Thank you.